Hello. The topic of our today's video is structure padding and packing in C. So, what is structure padding? The formal definition of structure padding is this: the process of aligning data members of any particular structure in accordance with the memory alignment rule specified by the processor is called padding. But what does this definition actually means? To understand it completely, we need to first understand the concept of data alignment. So, what is data alignment? Let's assume a situation where all the memory of the computer is byte addressable. That is, it is arranged in a sequence from which we can read or write only one byte at a time. So, what will happen if we need to fetch the integer variable? It will require 4 memory cycles for a single variable, which is highly inefficient and slow. So, what can we do to make it more efficient? So the processor does that. It specifies the word size, which is equivalent to the size of the underlying bus, I mean data bus that it is using. What this ensures is basically maximum number of bytes can be processed in a single memory cycle, which will make it more efficient and speedy. Okay, so what is its impact on structure padding? So basically in C, what compiler does is it allocates the memory for a particular data member of a structure in the multiple of 4 bytes. Okay, so if it allocates memory for a char, then also it allocates 4 bytes. If it is allocating memory for an integer variable, then also it is allocating 4 bytes. And if it wants to allocate the memory for a float value, then it will allocate 8 bytes. That is 2 into 4 bytes. Okay, so to understand it more, let's go through the C code. Yeah, so we are making a program in which we will see the size of the variable. So here I'm including a basic header file. Now we will define a main function, which is the starting point for any C executable. Basically before that we need to define a structure. Struct size def. Let's say we define char a int p, then char c. And now here we will make the object of the structure by like this: size def obj1, and then we will print the size of this object. What it will say: the size of structure object is %d, and we will be using size of operator. Okay, and then we will compile size.c. Oh, there is some error. Okay, now we will be executing this program, and it will tell you the size of the structure is 12. But how? We have defined 2 chars and 1 int, which means there is only 6 bytes required by the structure. But how come its size is 12? Let's go to program again. So in this case, what the compiler is doing, it is allocating 4 bytes for this particular character variable, which is a, then 4 bytes for variable int, which is b, and then again 4 bytes for the variable c, which is of type char. So basically it's the wastage of space if we see. So it's not a very good way to define the structure like this, but this program will fairly give you the idea of padding basically. So padding is basically the size of any object of the structure will come out in multiples of 4, because the C compiler will allocate the memory for each variable in multiples of 4 bytes. Okay, so it can be defined in a better way. So it is advisable in C to define structure members like starting from the longest size variable to smallest size. Like if we have the variable double variable, integer variable, character variable, so it is advisable to define it in the descending order of the size. So you should define the double variable first, then after that integer, and thereafter char. So multiple character variables can be accommodated in a 4 byte chunk that compiler is allocating for a variable. Okay, so let's modify it like this. Now see what difference does it make. We will going to compile it again. Now we will run its executable and see the size is reduced to 8 bytes. Okay, so what does that mean? If we see the program again, then compiler now is allocating 4 bytes for this integer variable b, and it is allocating another 4 bytes for variable a and c. So these both character variables are accommodated in one 4 byte size chunk. Okay, so it is the efficient way and the suggested way of defining members inside a structure. So basically this is data padding. So this is instead of 6 bytes, the size of this structure is 8 bytes to make it compatible with the alignment rule specified by the processor. Okay, so this is we call structure padding or data padding. Now we will see what is structure packing. In this program we can do one thing. We can say pragma pack 1. Okay, and now if we compile this program again and run the executable, now this size comes out to be 6, which is the original size that everybody expects to be of the structure. So this is structure packing, basically compressing the data members of any structure as according to the size defined by the actual size of the data type of that variable. Okay, so here in our program, this pragma pack 1 specifies that pack this structure in multiples of 1 byte memory, not in 4. So that's why it is allocating 4 bytes for this integer, 1 byte for this character, and another byte for this variable character c. So that's why its size coming out to be 6. But this sometimes cause the problem of data alignment for bigger structures. But for this video we are signing off with this note only. We will continue this topic further. Thank you.